Alright, ladies and gentlemen, in this video we are opening up our discussion of areas of polygons, and the whole goal of this entire unit is to find areas of rhombi, kites, be able to find angle measures of regular inscribed polygons, and find areas of regular polygons in general. For this particular video, the success criteria that we are going to be diving on into is you're going to have to be able to find the area of a rhombus or a kite using its diagonals. So let's take a look at our two formulas for the area of a rhombus and a kite. So rhombus and a kite, obviously somewhat similar in shape and form. They have different characteristics, very different characteristics. Remember, a rhombus was a type of parallelogram. We knew that all sides were congruent. Opposite sides, of course, were congruent. Opposite angles were congruent. The diagonals bisected each other. Diagonals were perpendicular to one another. And there was a lot of information about all the different parallelograms. For a kite, if you remember correctly, they had only one pair of opposite congruent angles, and their consecutive sides right here were congruent as well, and the diagonals were perpendicular to one another. All right. That might just help us out in just some different scenarios. But again, for our purposes in this video, we are specifically going on into utilizing diagonal 1 and diagonal 2 to go ahead and to find the area by using half of the product of diagonal 1 times diagonal 2. Now, we're going to stay very basic in this example. Keep in mind, there could be a lot of other different techniques and scenarios that may have to come up and use that to find some lengths of the diagonals and so on and so forth. Let's take a look at a couple basic examples. Find the area of each rhombus or kite. Well, here in our very first one for part A, we know that the area of a rhombus is half the diagonal 1 times diagonal 2. Well, there's diagonal 1 and there's diagonal 2. So the area would end up being 1/2 of the product of 8 times 6, which ends up being 48, and 48 divided by 2 is 24 meters squared. For part B, we see here, once again, we'll call that diagonal 1, we'll call that diagonal 2, and we end up saying that the area is 1/2 of 10 times 7, which would end up being 70 divided by 2 for 35 centimeters squared.